So what is a function we saw first? Okay, function is a group of statements. It has a name. And then we saw how to define a function using def keyword. Every function has a name and parameter written in the bracket, followed by colon, and the indented statements. All the indented statements belong to the function. And then this square, which I have drawn, this is the main portion because execution starts from here. Now this line b is equal to square a was known as call, function call. And the value returned by the function is always returned at the call. Right? These things we saw. Then we saw one function called max, which finds maximum of two values. And we use that function to find maximum of multiple values by calling the function repeatedly, one after the other. Then we saw that a function may not have any parameter and function may not return a value. A very simple function we wrote, this one, def show. You can see no parameters to show. And it is printing something on the screen, but it has no return statement. Return statement is missing here. So a function may not have a return statement. Function may not have a parameter. It depends on our need, why we are defining some function. Then we were actually, we did not complete this topic. We were seeing how to pass parameter to a function. This parameter which we write or argument in the bracket, we were looking at this. And very important concept that we learned is that whenever we pass an integer, like a is an integer, when we pass that, you see I am calling function f by passing value of a, then whatever changes occur inside the function to that parameter are not transferred back. So although inside the function x becomes 2, but when we come back from the function, a remains 1. But to explain this, now I will slow down a bit. To explain this, I spent a lot of time in telling what is passed over here. See, anybody would say that a is 1, so a is integer, and fa means we are passing an integer because a is an integer. So we are passing 1. We are passing 1. But that's not correct. We are not passing 1. We are passing literally the reference. Because internally, when 1 was stored, a is 1, then a is a reference and it points to object which stores 1. So what really happens is that when we pass a, the reference gets passed. And this x is a new reference which refers to the same object. So when we say x is x plus 1, anybody would feel that, yeah, x should become x plus 1 means this should become 2. This value should become 2. But we have been repeatedly saying integer objects are immutable. Once something is stored inside that object, then integer object cannot change. So what happens due to x equal to x plus 1 is a new object is created which stores 2. As you can see, new object is created which stores 2. And we have said x, you become x plus 1. So x refers to that new object 2. But a, original reference which we passed, is still pointing at 1. So that's why, when we come back from this function, a is still pointing to the same object which is storing 1. So this all things, I told, and it took a lot of time actually on that day, I remember. But then what I said afterwards is that all this was explained, that like these references and all that, to prove that why changes are not reflected back. Why changes are not transferred back. But in the GATE exam, when you are asked what is the output of this code, then in the rough work, you should not waste your time in drawing this reference, then object, and trying to recall what is happening. You should simply say loosely, you should say a is 1. So we are passing integer a. Integer a is caught by x, so x is 1, correct? Then x becomes 2 inside the function. But you remember that fundamental. Although x becomes 2, a remains 1. This is the way how you have to catch up. Okay. Then we further practice this a bit. Like we defined a function with two parameters. Both parameters were increased and decreased. Then a and b is 1, 2 respectively. We are calling f of ab. That means we are passing 1 in x and 2 in y. But whatever changes occur to x and y, a and b remain unchanged. So when we come back from the function, a and b printed will be 1 and 2 only. So that is the first output. And again, if we call the same function, passing b and a, so b will go in x and a will go in y. But forget it, whatever changes occur in the function to the parameters will not reflect back in b and a. So a and b will remain same. We are printing a and b. So 1 and 2 will be the output. Okay. Next, we again practiced it with more examples like this. Then I thought what happens when return, because Amit asked what if the function returns a value. Still, whatever changes occur in x and y are not reflected in a and b. But suppose the return value you copy in a, you watch a is equal to f of ab. Then a will catch up the value returned by the function. But a will change now, agreed. But a will not change because x and y has changed. Please try to understand. That return value has gone in a, that's why. These things we saw. Correct? Then I wrote a note. Whenever you pass int or float or boolean or string or tuple to a function, all these examples were about integers only. We were passing integers. But I wrote, if you pass any of this, you remember these are immutable. But list, set, and dictionary are mutable. So we are in this list, we are talking about immutable things. When these are passed to a function, then original argument passed never changes. So again, one example we saw, a is 10.5 and fa is called. So a goes in x is 10.5, then x becomes 11.5 here inside the function. But when we come back from the function, output is still at 10.5. Correct? And there we stopped. Okay. Although a very, very quick revision, I should not call this as a revision, but it was expected that you are still in touch with all this. So what we will now, today, what is the plan? We will continue with learning about function, and we will continue this topic, passing parameter to function. This topic is continued. Okay, let's see. Pass a list. Let's see how to pass a list to a function. Nothing extraordinary. But imagine I define a function like this. Define f x colon. So x is the argument and some function is there, and here is the main part. I'll write the function later. Here is the main part. A is the list storing 1, 2, 3, 4, 5. Simple list it is, square bracket. And now I call fa. So obviously this list A, will go in x. And inside the function, I write x0 should become 100. That's it. Only one line is there. I am not even returning any answer, returning any value. Function will simply catch x and then play with the 0th index. It will make it 100. And after that, we come back here and we print. I'm so sorry. Print A. Yeah. Correct. Now, it is not difficult to know that. Obviously, you got the answer. When we print A is the list, the output will be 100, 2, 3, 4, 5. Because we have passed the list has gone in X, and X0 has changed. So A0 has changed. What is happening really? Let's see. Let's see this main portion. What is happening here is that A is a reference and it points to object. Which object? List object. Object of list class. And this is storing 1, 2, 3, 4, 5. Correct? Now this is the call, you see, function call. So we are passing A. Now when we are passing A, then we are not passing all the values. Check my words. We are not literally passing that list. We are only passing the reference. Small reference is a small variable which hardly stores address. Address of that location where the object is in the memory. It's a very small variable. And that reference goes in this way, in this parameter X. So there is one more, X is also a reference now. Because A is a reference, X is a reference. And X becomes equal to A. Come on, we are passing A, isn't it? A goes in X. That means this reference X refers to the same object to which A refers. You should appreciate the idea implemented by Python. How quick this call must be in terms of time and in terms of memory also. How quick the call is. Suppose this was not done by Python like this, and Python said, okay, you are passing A, that means you are passing a list. And it literally passed all the values. You can imagine that list 1, 2, 3, 4, 5, 5 values are flying to the function. Obviously, this list has to be copied again in temporary list. In the argument, this list will have to be copied, and that copy will take some time. And the copied list has to be stored somewhere, so memory will be occupied. Correct. Now here, the problem is not so serious because this is such a small list. Just imagine in reality, you had a list which contains 10 lakh values, which is possible, very big list. And you are passing that list, no problem. However big list might be, just a small reference is getting passed. This happens so quick, isn't it? And that X is referring to the same list. Now you just observe inside the function, if I say X is 0, then we are actually working on this element, isn't it? Because X0 and A0 both are same. Then X0 will become 100. And list is mutable. You can peep in the value and you can change it. And then the function is ending. That's the only statement. And when we come back here, obviously the output will be 100, 2, 3, 4, 5. This will be what happens when we actually, pass a list. We can change values in the list using that same reference. But one more important thing you never forget. What happens, when the function is running, then X is looking after that list. Because X knows where the list is. And when the function ends, that X is destroyed. Whatever arguments, parameters are made by Python, are created by Python for the function, those parameters are automatically destroyed when the function ends. So when we come back to the main, X is no more there in the memory. There is no reference called X. But A is still there. And A looks at the same list and says, oh my God, what happened? Because I was looking at a list 1, 2, 3, 4, 5. And now I have a list 100, 2, 3, 4, 5, which is very much possible. Because you passed the reference to the function peeped in the list and changed it. Moral of the story is, list is mutable. When you pass list to the function, And when you work with some individual element, the changes will be reflected back. That doesn't happen with integer. We saw it so many times. Or that doesn't happen with float. We saw it so many times. Because float is immutable. Even if you change the value of a float inside the function, original value will not change. Okay, so let's write that observation over here. Check that observation is, if list A is passed, list A is the list, is passed as parameter, then reference X is the reference in the function. Reference X refers to same list A. Same list A. And hence, the changes are reflected back. Now, I have a question and I want all of you to give me the answer for this. Huh? What will happen? How do I go for a new page? Yeah, pages. Correct. Now, just tell me, what is the output? What is the output of this code? Huh? I'm defining a function fx and I am saying x should be let's say 6, 7, 8, 9, 10, or let me reduce it, 6, 7. X should be 6, 7. That's it. That's the function. Then in main part, A is 1, 2. This is a list of two values. I am calling the function by passing A and then I am printing A. Now notice I am passing a list to the function and I am changing X over here. Correct? X is changed. Like we did in the earlier, X0 equal to 100 we did. Here also we are changing X. My question is, what will this print? Will it print 1, 2, original list, or will it print 6, 7, the new list? Is my question. Just check the code. Let's start from here. A is referring to list object, which stores 1, 2. Now, this is a function call. We are passing reference. Reference goes in X. So X is a reference which refers to the same object to which A refers. Correct? Then we are saying in this line, X should be a list. You can see what we are doing, we are assigning X to a new list. X should become a list, we are saying. 6, 7. Then a new list object is created. This is a new list object created inside the function. Inside the function. And who should point to this 6, 7 list? X. So X now does not point here. Okay, better way of drawing it was, X was referring to the original list. Now X will not point here, but X will point to the new list, which stores 6, 7. This is what happens when you assign a new list. And then the function ends. When the function ends, and when we come back, when we are printing A, A, then A is looking at the same list 1, 2. And one more thing you don't forget, that when the function ends, that X itself is destroyed and that object also becomes garbage. That is also destroyed because that was created when the function was running. That is, there is no list 6, 7, there is no reference X when the function ends. This may happen to be confusing initially. That's why many boys and girls often say that the output will be 6, 7, because just now we saw in the earlier example that changes made in the list are reflected back. But which changes are reflected back? When X was referring to A in the earlier example, and when actually we were playing with individual values of that same list, then we were doing changes in the original list. But when we assign a new value, new slide, when we assign new X, and you say X, you become entirely a new list. Then X leaves that object and points to the new object. So A remains 1, 2. So when we come back, the output is 1, 2. Okay. Purposely, gate people will ask some question like this. Anyway, but first let us write the comment here that new list 6, 7 was created inside the function, in the function. The reference X now refers to the new list. The list A remains 1, 2. No change here. Okay. Now you see this question. By the way, I hope, I'm sure you remember this concept of swapping of anything. Like, let's say I'm having a B equal to 10, 20, and I want to quickly swap the values of AB. We can say AB is equal to BA, like this. This is possible in Python. So A will take the value of B and B will take the value of A. Swapping. This was due to packing and unpacking of tuples. Okay. Now, how they may fox us, you see. This is really foxing. The question is, what will be list A and list B after execution of this code. Just see. Define a function f a comma b. A comma b is equal to b comma a. Let's say that's it. We have passed a comma b, and we are saying here a b is 1, 2, a list. B is 6, 7, and then we are saying f of AB. And finally, we are printing both the list. Print A, print B. Both the list we are printing. Now you see, anybody would feel that A and B are the lists. And this is the function call. We are passing these two lists as references. And we are interchanging. A comma B equal to B comma A. So it seems that when we come back from the function, then A will be 6, 7. A will take the values of list B and B will be 1, 2, like that. But let us see what happens. Okay, first, what, to avoid confusion, I just change the names of this parameters. But names can be AB. I will come to that. Just to avoid confusion, I will again write the same code with AB. Okay, but right now, let's say XY colon, then XY is equal to YX. Like this I have written. I hope this is visible. Okay. XY is equal to YX. So, see, in the memory, we are having a reference which points to list object, which stores 1, 2. And we are having a reference B, which refers to list object, which stores 6, 7. Correct. Now, this is a function call, you watch. And reference A goes in reference X, first reference. So, X now refers to A, wherever A refers. And reference B goes to reference Y. So, Y is a new reference which refers to B. And now, the interchanging is happening. But interchanging of X and Y is happening. That means X should refer wherever Y is referring and Y should refer wherever X is referring. It is clear that now it will say, okay, Y will say, okay, I will refer wherever X is referring, and it will discontinue pointing here. And X will say, I will refer wherever Y is referring, and it will discontinue pointing to 1, 2. That is all what will happen. Original references A and B are not interchanged, correct or not? And when we come back, we will see the same list in A and B. This is clearly saying X, you refer wherever Y is referring, and Y, you refer wherever X is referring. So when we come back, A will be still 1, 2, no change, and B will be still 6, 7. Correct? I'll just draw it neatly again. This was what we had in main. A was pointing to 1, 2, and B was pointing to 6, 7. And when we called the function, then X started referring to A and Y started referring to B. But now we are swapping reference X comma Y inside the function. Correct? Hence, what will happen is that A will still point to 1, 2. And B is still pointing to 6, 7. This is not going to hurt them, 6, 7. But now Y will refer to A and X will refer to B. That is what happens in the code. But A and B are still 1, 2 and 6, 7. That says it all. Okay. I hope this is clear. So, no changes are transferred. Changes occur in the references X and Y. See, oh my God, what did I do? Just a second. Good Lord. What do I do now? Let it be like this. Okay. By the way, so we said that when we pass a list, then any changes made to the list will be transferred. We said that, correct? But it will be transferred if you work on individual element, like in our first example. In our first example, when we passed the list, X was pointing to the same list. And then X used some index and it went to the element and it changed it. Only then it will change. If you assign a new value to X, as in our second example, we passed A and then we assigned a new list to X, then original list will not change. X will point to a new list. When we swap the parameters, then the references will get swapped. Original references will stay wherever they are. Okay. Now, I'll just write the same code again. Just the same code. Same code as above. Written again over here. Suppose I write the parameters as A comma B, let's say. This was what I wrote and then I changed it to X and Y. A comma B is equal to B comma A. Now in the main, I am having A is equal to 1, 2. B is equal to 6, 7. And now I am calling the function FAB. Correct? Then I am printing A. I am printing B. See, you should not be confused here. That function has been called as f of AB. So A and B are references. And the parameters of the function are also AB. You should not get confused that, okay, that means now they are the same references, not the new reference which points to original object. You should not get confused like that. You stay with the basics. See, whenever we pass argument, that argument goes this A, this A, this A, this one, first thing passed goes in the first thing here. Correct. Then this is a new parameter always created. You may say, but names are same, sir. Let them be same. Because once the Python goes inside the function, then it creates local parameters, local to that function. Okay. So what really happens is still the same. Still the same. You should not get confused. You may get confused because parameter names are same as the original list. So you may think that now the original lists are getting swapped. Nothing like that will happen. You see, still A is referring to 1, 2, and B is referring to 6, 7. Correct. And now this is the call. So A is a reference, B is also a reference, both are list references. They will go in new references AB. So A will refer wherever A is and B will refer wherever B is. This may appear strange initially, but every function, has been is always allocated its own space, separate space, where it is given freedom to create its own variables, its own parameters. Now, you see, when we are swapping A and B over here inside the function, then we are actually swapping these. These parameters are getting swapped. So when we say A comma B is equal to B comma A, still you know that this B will now point here and this A will now point here. That's it. This is the only change which is occurring. But the original A and B are still unaltered. So when we come back, A is still 1, 2 and B is still 6, 7. So moral is that parameter names can be same as original values passed. If you are passing AB, parameters may be AB. Then you stick with the concept that this is a new parameter created, which points to the same list as original A, and then work according to what statements are written. Okay. So the output here is still 1, 2 and 6, 7. So I'll just go to Python idle. I have not switched it on yet, but it is important, sometimes to confirm that whatever I am speaking is correct. Okay. So I have opened a new file, and let's say I define a function f a comma b. Okay. Then a comma b is equal to b comma a. Done. Backspace. I'm back in main, and in main I am saying a is 1, 2 and b is 6, 7. And then I call the function f a b. And then I print a and print b. The output expected here is 1, 2 is a and 6, 7 is b. We are saying that the parameters got swapped. Original list references were not altered. So I'll save this with, as usual, my favorite name trial. I will overwrite that file. Okay, let's run this. Rightly so. This is list A and this is list B. No change done. Correct. Whereas, let's say I don't do something like this. Just imagine I say A0 is equal to B0. Let's say. Now you know something is getting changed in list A. Correct. And list A will now store 6 over here because A0 is becoming equal to B0. B0 is 6. So the output will be 6, 2 and 6, 7. Now there will be change in list A. List B is not changed because it is only used on the right hand side here. So when you confirm this, yes, it is 6, 2 and 6, 7. Isn't it so? Okay. So, whatever I told you about list just now, same thing is applicable with set and dictionary also. Okay. So instead of teaching, instead of telling or I will write the code and I'll ask question that what will happen. Remember, set and dictionary is also mutable. Correct. Although in the set you cannot change individual value because index is not there in the set, but you can add some new value or you can remove a value from a set. So here we go. Still we are continuing passing reference. Okay. The point is pass a set to a function. Let's say I write define f x. X dot add 20. That's it. Only one line. Then I am defining one more function g x. X equal to 100, 200, 300. Okay. Now there is a main part where I am saying A is, let's say 1, 2, 3. Okay. And suppose I call FA, then I call GA. See, I am calling both the functions. And the question is, how many elements will set A contain at the end, of course. How many elements will set A contain when this code ends? So what do you think? How many elements will, of course, the execution will start from here. And same concept applies that A is a reference and it refers to a set object. Set object has 1, 2, 3. Then when we are calling f of A, then we are passing a reference. That reference goes to f function. So x is a new reference. X refers to the same object. And so on, so on. So what do you think finally will be the number of elements that set will contain? See, it will be a very bad option to ask what will be the output, because set is unordered. So nobody can give strict output, whether it will be 1, then 2, then 3, or whether 3, 2, 1. So it will be a very wrong question to ask. Okay, so that's why I have asked how many elements will be there. Question was, how many elements will set A contain? So will it contain 3 elements or will it contain 4 elements, like that? I am asking length of the set, length of set A. Set A. What is the length of this set A after the code ends? Add is a function, correct, Amit? Add is a function which will add 20 in this set, correct or not? Because we are saying x dot add. So x dot add means we will add in the same set. So 20 is also added. We don't know the location where it is added, but 20 is added in the set. And then the function ends. And when the function ends, this parameter x will be destroyed, isn't it? We are back to main. And now A has changed. A was originally 1, 2, 3, but now A will contain 1, 2, 3, 20, like that. And now there is another call, you see, G of A. So what happens in this function g is x again refers to the original list A. But then in the function we are saying x, you store a new set, entirely a new set we are assigning. So there will be a new object which stores a set 100, 200, 300, and then x will discontinue pointing here. X will point here. You can see that A is still pointing to the original list, which is 1, 2, 3, 20. So the question was, what will be the length of set A? It should be 4. I hope you got that. After the execution, length of the set A should be 4 and not 3. One might think that now X has changed and it is now storing 3 values. So these 4 values will be erased, and instead of that 100, 200, 300 will come. But the reference has been assigned to a new set. Okay. So X will refer to a new set object. Original set will remain safe. So passing set to a function, I told you, is absolutely same as passing list, except for the fact that if you want to change the set, then only 2 operations you can do. You can either add or remove, that's all. There is nothing like x0 should become something like that, because set is not having indexing. Correct? Okay. So let's see passing dictionary. Pass dictionary to a function. Let's say I define a function f(x), and here I say x1 should become 200. Let's say that's all. That's the function. Now I am having dictionary A equal to, let's say, 1:10, 2:20, 3:30. And then I am calling the function fa, and then I am printing the dictionary A. Now again understand, A is a reference. A is a reference in this main. A is a reference which is referring to key value pair dictionary object. So this is object of dictionary class which is storing 110, 220 and 330. And remember, in dictionary there is no indexing like 0, 1, 2, but dictionaries are ordered by their keys. Now we are calling the function f by passing A, reference A. A goes in X, so X refers to the same object. And we are saying x1 equal to 200. So any statement of this kind means this is the key in the dictionary and right hand side is the value. So obviously x1 changes to 200, and value can be changed, but keys cannot be changed. So we are intruding inside that dictionary and we are changing some value associated with some key, which is perfectly possible. And when we come back from the function and we print this, then the final dictionary printed will be 1, 200, then 220 and 330. This is what happens. So now that we have seen passing parameters, just for a confirmation, I am writing one short code here. You tell me what will happen, okay, due to this code. I'm not giving you any hint. What is the result, I am asking? What is the result of the given code? Of the given code. Okay, here we go. Define fx. x0 is equal to A. That's it. Then here in main, I am having A is equal to Samir. So A is string. Then I call FA. I am passing a string and then I print it. Okay. So what will happen? If you feel that there will be some output, okay, you tell me what will be the output. Whatever you feel about this code, you may uh, reciprocate that on the Q&A or on in the chat box. We are passing a string now, and remember, string is also a reference. So this reference will go in that X. And then we are saying 0th index of X should become A. So one chance is that Samir 0th character will change and name will be changed as Amir. Any other, I don't know. What will be the result? Well, Samir said that original string will be printed because Samir thought that strings are immutable, so you can't change it. And function is trying to change some letter. And Amit said, no change, sir. Not possible, he said that. Not possible. Just see, there will be an error. It is not possible correctly. There will be an error here because original string cannot change. So this program will give an error at this line, you see. This line. String object does not support item assignment. You cannot change particular letter of the string. So you are clearly asking X0 to change. Huh? So Python will report an error and program will stop. So this, when the function is called, inside the function, there will be an error. So program will not reach this print. It will not print anything. In fact, program will not reach the print statement itself. So the answer is error at line X0 equal to A. And you know the reason. Strings are immutable. So can you pass string to a function? Yes, of course you can pass string to a function. And then you can use that string inside the function. Just use it. But you can't change particular letter of the string. Correct. For example, you can write for loop for that string. Go through each character and count number of vowels, maybe. Or any such kind of operation you may do. So now that we have seen about passing parameters, now let us come back to returning a value. Okay, we were always talking about function call. Then we may pass something and what we can pass and what happens we were seeing. Now let us talk about that return statement. Return statement is not compulsory. Sometimes function may not have return statement. So function does its work and silently ends. We have seen that. But the point is that let's talk about return statement. First point is a function may not have return statement. Make it very clear. May not have return statement. Okay. Second, function may contain multiple return statements. It is possible. Multiple return statements. Yeah, it's very much possible. Like if you are writing some function, def something, and some if is written, then you say return some value. Else if some condition, then return some value. So multiple return statements are indeed possible. Correct? Only one of them will run. It's not that all 3 or 4 return statements will return their values. Only one return statement will run. And most importantly, whenever return statement executes, function ends. I repeat, whenever return statement executes, the function ends. So whatever you have written below return will not run if return is executed. We saw that number of times. Correct. I mean, what I am saying, suppose I write define fx. Just see this function. If x is less than 3, return 0. Then I have written print x and return x minus 1. Again, I have written something which when I don't know what I have written. Something I have written. Okay, but first of all, this function you see contains multiple return statements. Correct. Now you tell me what will happen if you call this function like this. Z is equal to F2. F2. Just check this. First of all, some variable has to be written on the left now because function is returning a value. Z is equal to F2. So X becomes 2. Now the first if will become true. 2 is less than 3. Yes. Then return 0 is executed. As soon as return 0 is executed, function ends. Then in this instance, in this call, in this instance, rest of the lines will not run. Because if x less than 3 was true, so return 0 executes and z will become 0. What if I say y is equal to f4? Then again x becomes 4 here, parameter x. 4 less than 3 is false. So this return 0 does not run. Correct. This if is false. So this line does not run. Then next line runs. So it prints 4 because x is 4 and it returns 3. So y will become 3. Just a crazy example I have written just to tell you that multiple return statements are possible. First. Second, whenever any return statement runs, control goes back to main. Rest of the lines will not run. I hope that's very clear. Okay, I'm not keeping this example. And the third point is, I'll keep it for some time. Later on, I'll erase it. Third point is that function can return multiple values using single return statement. Single return statement. Just check, this is possible only in Python. This is not possible in C, C++, Java. Okay. That means what I am saying is, when you write return, in C, C++, Java, JavaScript, Visual Basic, whatever programming language you say, whenever you write return, you write only one value after return. Only one single value is returned back. But in Python, you can write return some value, comma, some value, comma, some value 3 or 4 or 8 or 9, however number of values you want to return, you can return. And this is possible only in Python. Let's see an example of this. We are talking about returning, concept of return statement. And the last point is very interesting. First 2 points, I was sure that you knew this, or rather they were easy to catch, right? But how would you accept this fact that function can return multiple values using single return statement, and how to use it? Okay. Yeah, return. Just check this example. Suppose I define a function uh, calc r colon r is the radius of the circle. Okay. And what I do inside the function is I calculate the area of this circle, pi, that is 3.14 into r into r. I could have written r raised to 2 like that. And then I calculate the circumference of this circle, that is 2 into pi into r. Okay. Now, what I am doing in this function is I am passing only one value, radius of the circle. And what I want to do is I want to calculate area and circumference and return both. So what I will do is return a comma c, like this I'll write. So this function is returning multiple values. Back at the call, remember, value is always returned at the call. This is the point here to be understood. So in the main, suppose I write area, comma, circumference equal to calc 2.5. So you know that this is a function call, calc 2.5. So r will be 2.5, this radius. So area will be calculated in the function, circumference is calculated, and then the function is returning both a comma c. So both will fly back here at the call. Area value will come, circumference value will come on the right hand side over here at the call, and then easily left hand side area will become equal to a and circumference will become equal to c. But you recall, all this is possible, only because of packing and unpacking of tuple. We don't even notice actually, that when we write return a comma c, you notice we have written two values back to back separated by comma, barely like that. And way back we had a lesson that whenever in Python we write list of values without any container, without any wrapper, then Python will automatically put those values inside tuple. So actually, this return a comma c is like this. It is returning a tuple. Yes. It's not that, it is returning a and c. So it throws a, then it throws c. Take these two values. No, no, no. That values of a and c are bundled nicely in a wrapper. And that wrapper is a tuple. And that single tuple, is thrown back. Now this person, who called the function calc 2.5 will get that bundle and then unpack it. When it unpacks, it gets first value A, which is area, second value C, which is circumference, and then disperses it to the left hand side. So next time when you are asked, can Python return multiple values using return statement? You say yes. Can C language do that? You say no. When you are asked why, then you tell that this packing and unpacking of tuple procedure of this allows you to do this in Python. And easily, obviously, after that, you will print both area and circumference. So, I would like to go to Python idle and let's see tuple in action over here. Although in the entire code, there is no tuple seen anywhere. But tuple gets built on the fly due to that barely written values a comma c. So it bundles it into a tuple and then throws the tuple. So isn't it actually, what to say? Isn't it wrong to say? Yeah, it's wrong actually to say that Python can return multiple values using single return. It's wrong. Because although you are writing multiple values like this, but it gets stored in single tuple. So actually it is throwing one tuple back to a call. It's like that. But overall, we can say yes, it can return multiple values. Agreed that multiple values get bundled in a tuple. Okay, so I'll go to idle. I think it is open. I'll type a new file. Of course, new file is going to be trial only. Huh. So imagine I write def calc r. R is the radius, and I say a should become 3.14 into r, and c should become 2 into 3.14 into r. And then I am returning a comma c. Two values I am returning. You know they will get returned uh, as a tuple. You saw one more thing just for fun. Huh? When I typed return a comma c and hit enter, then cursor automatically got outdented. Did you see that? Actually, when I typed this line, c is equal to 2 pi r and hit enter, then cursor remained indented inside only. But when I said return a comma c and hit enter, you see cursor is outdented back. So even Python idle understands that as you are writing return, your function ends here. Correct? Yeah. So now, what did I say? Suppose AR is the area, comma, CI is the circumference, equal to calc, this is the call to the function, 2.5. Okay, and I print AR, comma, CI. And I will, did I write SI? No, no. Save this as usual trial. Oh, multiple edits. I think trial is open somewhere. So it's saying, how are you storing? This is too much. It is saying, okay, I'll just close that. Okay. This is trial now. You can see this is the value of the area, AI, and this is the value of circumference, CI. Okay. But what is more interesting, suppose I don't give two variables here. I give only result like this. Result is equal to calc 2.5. I know that calc is going to return two values, area and circumference. So on the left hand side of the function call, I should have two variables, but I give only one variable. Then what will happen is, you see always, here tuple will be returned because you are having something, comma something. So tuple is returned. So this right hand side will get a tuple. That is, in the bracket, it will receive the value of area and circumference. Then left hand side is a single variable. Then unpacking will not occur and result will be purely a tuple. Let's see what will happen when I print result. Oh, good Lord. You should see again, area and circumference have got printed, but you should not neglect these bracket. That means the right hand side, the calc, the function call got a tuple and we did not unpack the tuple. We did not write two variables on the left hand side. We wrote only one variable. That's okay. Then it caught the variable that it caught the value as a tuple. So result is a tuple. Correct? So what will happen if I say result 0, print result 0, comma, result 1? Now I am individually printing 0th value of the tuple, first value of the tuple. Now bracket will not get printed because I am printing individual values. So this output will look exactly same as what we were doing here. Correct? Although we have not unpacked it, we have taken it as a tuple, but we are taking 0th element and first element and we are printing it as you like. You may disperse it in multiple variables. You may take it in a tuple and then work with 0th element, first element, and so on. I hope you understood. Returning multiple values. However number of values you may return from here. In some other example, maybe you've got 3 values to return. You can. Just check this example. Now that we have seen that there can be multiple return statements, there might be no return statement, and return can return multiple values if necessary. This also we have learned. Now, the one more aspect of function that I will tell you is about variables inside a function. See, now I am no more talking about this parameter or argument. I am talking about variable inside the function. You see, when calc function started its execution, there was a variable a, suddenly variable a popped up and it was storing a value. Then C got created, this variable. These two variables, were created when the function was running. When main is running, there were no such variables. These variables are created inside the function. And such variables, which are created in the scope, in the boundary, in the limits of the function, are called local variables. Whereas variables which are declared and created in main section, this is the main part from where execution starts. These are also variables, isn't it? Which store the value returned by the function. These variables are called global variables. So there is a concept of local and global variable. in Python. So what is a local variable? Variable that is created in the boundary of the function, inside the function, is called local variable. And variable that is created in the main part of the Python program, from where the execution starts, is called global variable. Now the point is that these local variables, can be used only within the function. Because when the function ends, these variables will get deleted from the RAM. From the memory, they will get deleted. Plus plus Java, Python, JavaScript, Visual Basic, whatever you say. This is called as garbage collection. Because once the function is finished, then whatever temporary variables were created in the function are no more of no use. They must be deleted from the memory. Even this parameter is deleted from the memory. Whatever local things that got created when the function started, those local things are removed from the RAM, from the memory. Okay. So we are talking about local and global variables. Just check what is local and global variable. What is local? Variable created inside the function is local variable. And remember, this variable can be used only in the function, because when the function ends, that variable is deleted. So no question of using it outside the function. So local variable can be used only inside the function. And global is exactly opposite. I mean, variable created in the main part. in the main part of Python code is global. And the point is that you are free to use this global variable anywhere. You can use it in main part. You can use it in the function also. So such variable, that is global variable, can be used throughout the program, anywhere, throughout the program. That's why it is public, It's a public property, and there is no restriction. Like for local variable, there is a restriction. Just make a note of it. We are going to see several examples of this. Although, it's very surprising, although only 2 papers have been held till now, but local and global variable is one of the aspects, which will be very soon handled by GATE people. I think so. Because there is a lot of scope, especially in the functions chapter, to check your knowledge on which variable can be accessed where. And I will solve several examples of local and global variables. Just make a note of it. Okay. So what I will do is I'll write codes again to explore this concept. And let's see, for examples to explain local and global variables. Global variables. Very senseless codes we will write. You know what we are doing. We are learning concept. Okay. So suppose example 1. We are having a function like this, def, no parameter. Very simple function I am writing. And suppose I write x is equal to 10 and print x. Then here is the main part. I have a is equal to, let's say, 50. Then I am calling function f, and then I am printing x. Okay. See, such codes, are many times very difficult to understand to the beginners. Although the code is very nominal, nothing extraordinary in that. But why such codes, are very difficult sometimes? Because these are meaningless codes. But you know what? When we type this program, we will get error. And error will be at this line. Okay. And error will be undefined symbol x. Some error like that. Undefined symbol, undefined variable x. Then you will wonder, I have defined x equal to 10. I have defined so clearly over here. I have defined x. Then how I am getting error x not defined? Correct. You have defined x, but you have defined x inside the function. Then when the function ends, when we are in main, you don't have any access to x. X can be used only in the boundaries of the function. Correct. So what will happen when the program runs? A is 50. Execution starts from here. This is global variable because it is part of main code. Then we are calling the function. Such a simple call, you see, because function is not taking any parameter, but still we have written empty bracket during the call, and function is not returning any value. So nothing on the left hand side of the function, you can see. Okay. So we are calling the function. Till now there is no error. Then when the function starts, suddenly new variable is created. X becomes 10. This is called local variable. Now there are 2 variables in the memory. First one is a, which is 50, but that is global variable. Second one is x, which is 10, but this is local variable created inside the function. Then function prints X. So 10 is printed. Yes, still there is no error. 10 is printed. Then the function ends and we come back to main. Of course, next line will run after the function call and we are trying to print X, but X has died. X was killed from the memory because the function has finished. You are coming back here and trying to print X. Now it will give an error. This proves that local variables can be used within the scope. So in this code, this X is local variable. Local variable. And this A is global variable. This print X will give an error. The reason is local variable X cannot be used. Sorry for the handwriting. Cannot be used outside the function. Outside the function. Correct? Just check this. So what I will do, I will go to Python idle because we will be rapidly seeing many such examples about global and local variables. We may mix up with parameters also. I may write some example where there are some parameters and we may come back to list and tuple and set and dictionary also in this examples. Okay. So I'll just go to trial.py. I'll overwrite this file itself. Let's define a function f, very simple function, in which I am saying X should become 10 and print X. So I am creating a local variable and I am printing that value. That's all. I now have to hit backspace because that's all my function is. Then I am having a global variable. A is, let's say, 50. Then I am calling the function f and I don't know why, but I am printing X. Although I can print X here, this is legal, but using X over here is illegal. So if I save this and run this, you can clearly see one output is shown, 10 is shown. Because till that point, there was no error. Function got called, function started, X was created, X is 10. Then print X, we printed 10. Then we came back. When we came back, oops, it said who is X. So 10 was printed by the function and we got an error. Let me do this. Can I scroll this? Wait a minute. Yeah. Just check. Name X is not defined, it is saying. And the error is at this line, print X. This proves that local variable was created, was stored, even got printed, but outside the function, it is not available. Okay. Now, I'll change the code. Here, instead of X equal to 10, I'll write A equal to 10. Like this. Printing. Okay. Stick to the rules. This A is global variable. Then we are calling the function f. When the function f starts, A equal to 10 is written. Then this variable A is a new variable. This variable A has got nothing to do with that global variable A. Now the function is saying that I am having my own variable A whose value is 10 and this is my local variable. So please try to understand that there can be a global variable with name A and there can be a local variable with name A. Both variables are different. Then this function is going to print A, which is 10, not 50. Here the output will be 10, not 50. Then when we come back, of course, there's no question of X now. When I print A, this A, this A, which I am now finally printing in main, has nothing to do with local variable. Now it will print the main A, correct or not? I hope you are understanding. So there won't be any error here. The output, the first output will be when the function is called. That will be 10. When we come back, 50 will be printed. So let's see. Yes, you can check. The output is 1050. So can local and global variables have same name? Yes, of course they can have same names. I hope you understood this. So I will write this code on the board. Just check. I will make it clear that example 2 is local and global variable can have same name. So suppose I write define f, no parameter, and inside this I write a is equal to 20, print a. Then make it clear this is a local variable a, which is 20. And now in the global section, when I say a is 10, then this is global variable a, which is 10. Now when I call the function, only then that local variable is created. So new variable a is created whose value is 20, which has nothing to do with the global variable a whose value is 10. So this is a new variable. Then that variable 20 will get printed, not 10. Here the output will be 20. And when the function ends, that variable will be destroyed. Local variables are killed when their scope, when their boundary ends. And when we come back here, when we try to print a, obviously a will be 10. So the output of this code is going to be 2010. This is the value of local A, and this is the value of global A. I hope you got it. I thought of writing that program which we were seeing on the idle. This program. So I will write a short code here and let's see what's happening. Just see, this is so confusing. When I initially learned this, I said enough is enough. Because, we come from family of C, C++ and Java, which are so structured. Trust me, those languages, are very, very structured. But in the event of making it simple, Python made it more complicated. And of course, the person who tries to learn this only will feel it complicated. But as usual, after so many years, I have now pinpointed it in one statement which clarifies everything. But listen, now let's talk about global variable. A is a global variable and it can be used anywhere. Imagine I remove this a equal to 10. Now look at the function and just check what will happen here. Okay. First main will start. A is 50. This is global A. Then the function is called. So the function begins and function has only one line, print A. So value of variable A should be printed. Now the function f will check first. Is it having a local variable A? Function f says, no, I don't have any such variable A of my own, but I am asked to print the value of A. Oh yes, there is a global variable A. And global variables are accessible everywhere. So now the function f says, because I am not having my own variable A, I will now print the value of global variable. Come again. If there was a line here like this, A is equal to 10. What did I say in last example? This A equal to 10 is a new variable now inside the function. This is its own local variable, and now it has got nothing to do with global variable A. And now when you print A here, it says, I have my own A, private A, I will use it and I will print 10. But in the case where there is no variable with that name and you are asking F to print that variable, function says, now I will borrow global. Now the output will be 50. Then the function ends, we come back and this output also will be 50. So if I save this and run it, you can see 50-50 is the output. Whereas in the earlier code, when we said, look, function, you make a new variable A. Now the function says, I will not use global variable. Why I should use? Because I am having my own private property with the same name. I will use my own property. So the output was 1050. So the point is, global variable are accessible anywhere. You can use it inside the function, outside the function. But when you do not have a variable with same name in the function. I hope I made the things very clear. Now global A will be used. Okay. So I will just write a short code now. And let's see what will be the output. Suppose I have A equal to 10 and print A. Then I am having define G, no parameter again. And suppose I am saying print A. Okay. And then A is equal to 50. Then I am calling F. Then I am calling G. And then again I am having print A. So execution will start from main. This A is global A, whose value is 50. Then the function is called F. When the function F is called, function says, wait, I will have my own variable A. This is my local variable A, whose value is 10. Now when I print A, I will print my own A. It is not even taking global variable into account. So A is 10. So 10 is printed. So first output is 10. Then we come back to main here. G is called. When function G is running, it has simply print A. Function G says, I am not having any variable with name A. Oh, hello, but there is a global variable A and I have full permission to use it. So 50 will be the output here. So second output is 50. Then we come back to the next line, print A. This will obviously print global A because we are in the main section. So output is 50. So the output will be 10, 50, 50. Correct? Let us save this and run it. 10, 50. So function F did not use global variable because it had variable with the same name. Function G used global variable because it did not have variable with the same name. It did not have a variable called A, so it borrowed global. Just check this code. Output is 10, 50, 50. Check it. I hope you understood this very well. Acha, by the way, tomorrow also we have a class at 5 p.m. 5 to 6:45. Tomorrow I will be starting with a very important topic called recursion. And I'll tell you, at least 4 marks question is asked on recursion in GATE. By now you must have understood. For somebody else, 4 marks are nothing. But for us, GATE smashers, 4 marks is a lot. Because we know that ocean is made by small drops. Uh, and that is interesting also. Recursion is but naturally truly interesting. Okay. By the way, now I will again change the code. Note that what I am doing is inside this G function, I'll write A equal to A plus 1. And this creates so much confusion. Good Lord, I said, what's going on? I'll not use the exact words, but but A equal to A plus 1. Now, logically, you tell me what should be your thinking over here? Logically. And I'm sure whatever you are thinking, is absolutely has to be correct. Logically, it has to be correct, but it is not correct in Python. See, now, let's talk about function G. When G is called, G starts, function G, and then we are saying variable A should increase by 1. Correct. Now, function G is not having any variable with that name. Did it create any such variable? No. Function G did not create any such variable. Then we saw that when function G does not have a variable created with that name A, then it takes global variable. That is what you were also thinking, surely. So anybody would say that function G, will increase that global variable A by 1. So global variable A was 50. Now that variable A will become 51. And it will stay as 51 because it has actually increased the global variable A by 1. A is a public property, isn't it? And public property is shareable like that. So anybody who modifies that global property is seen by public because it is public property. So anybody would claim that A was 50, then G started, function G started, and we are increasing A by 1. But function G does not have variable with name A. It does not have local variable. Then it borrows global variable. So that global variable A should become 51. And this print A should obviously print 51. And then when we come back here in main after function G, variable A printed should be 51. Again, I point out that global variable was changed to 51. Global variable was changed to 51. It is not that it will retain the value 50. Correct? If my college has kept a pen at the counter, it is a public pen. My friend comes, uses pen and breaks it. I don't know why. And when I go, what will I see? Broken pen. Will I see the original pen? Same variable is getting shared, na? Global variable. So anybody, logically will think that this is what will happen. So the output will be first 10 by the function f, then 51 here because A became 51 and 51 here. 10, 51, 51 will be the output. But this will give an error. Let's see. 10 got printed properly because function f had no problem. But function G has problem at this line, A equal to A plus 1. It says unbound local error. Cannot access local variable A where it is not associated with value. What's going on? What's going on? You don't answer my question, but you tell me any beginner or any programmer who has learned 2 or 3 languages would say this is bound to happen like this. It should happen, but it is not happening. What is Python complaining, is that you are telling me to increase value of A by 1. You have said A should become equal to A plus 1. But what is the initial value of A? Where is A? And you are shouting A is global, use global A. But that doesn't happen. Python has a rule here now. The rule is that if you want to modify the value of a global variable, check my words. If you want to modify the value of a global variable in such a way that you are using a global variable to modify, that means left-hand side is having global variable and right-hand side of the expression is also having global variable. When a global variable is used for modifying a global variable, then you have to write a special line and ask for permission. You have to write global A like this. Oh, a new keyword I am teaching, global. Actually, this is a request we are making. Python, please allow us to modify the global variable A. This is like a permission. I am going to use global variable A and I am going to store some new value in the global variable A. And to do this, you need to write this line, global A. Now this line is very well understood and global variable A will change permanently. It will become 51. Then this A printed will be, of course, global A because you have said that I am using global A. So 51 is printed. Then when we come back here, 51 will be printed because A has permanently changed to 51. Let us see this first. Yeah, 10, 51, 51. Rewind again. Suppose I have written this much. Okay. Is function G using global A? Yes, yes, yes. It is using global A. It is not having variable with the same name. So it is using global A and it is printing 50. But in this case, although G is using global A, it is not necessary to ask for permission. Please try to understand global A like this. This is a waste of time. You can write if you want, but it is a waste of time. When is it necessary to write global A? When you are not just accessing, you are not using, you are modifying global A, then it is necessary in Python to say that I want special permission on the global variable. Now you can change the value of the global variable, and most importantly, right hand side also should contain global variable. That is, global variable should become equal to global variable plus something or minus something or multiplied by something or something like that. Then it is necessary. Just check this. Now it will be 10, 51, 51. So can a function use global variable? Yes. Can a function modify global variable? No. It can't modify global variable. If you want to modify, you write global, keyword global followed by variable name. Only then you have that special permission of modifying the value of global variable. Okay. So I'll write this code on the board. The topic actually, here is global keyword. Example 3. There is a special word called global. Global keyword. Okay. If a function is only accessing, that is simply using such as printing a global variable, then it can freely do it or perform such an operation. But if a function needs to needs to modify value of a global variable. Value of global variable. Then permission is needed by using global keyword. Global keyword. This is keyword. Okay. So in example 3, suppose I define f. Sorry. Define f. And here I want to update the value of the global variable by 1 and print it. See, the function f is not having any variable a with that name. So we are actually, what we want is global variable a should increase. Then the statement global a must be written here. Global a, right? Here we are modifying value of global a. Hence, the declaration global a is global a, this declaration is needed. I repeat, just for using it, like printing it, global a permission is not needed. Okay.